So welcome everybody. We are here today to listen the beautiful and exciting projects that our students from the Data Science Bootcamp did. So after 24 weeks of intense and a lot of roller coasters, nice, good, bad emotions, we are finally here to see and to listen to the beautiful insights that they actually got coming from, let's say, all these hard and soft skills that they were learning during these 24 weeks. I say that it's a lot. Also working on Saturdays and so on. So I believe that next week you will be kind of released a little bit. At least Saturdays we will enjoy. Nice that the good weather is coming in all the countries, I would say. So nice that you are delivering now as well. Okay. So first of all, I would like to congratulate you all because, well, for sure that you did an amazing job. And well, this is just, to congratulate you all to survive, let's say, and to be positive and motivated and, learn that amount of things and so on. Okay. So remember that the presentations, they are going to last 8 minutes approximately, because then we are going to give some like 2 or 3 minutes for Q&A if somebody is willing to ask something, any curiosity and so on. Okay. So, well, let's start with Analia will be the first one that is going to present. So whenever you want, you can feel free to start sharing the screen and start explaining.
Breaking the ice.
Yes.
All right. Okay, can you see my screen? Yes, right. All right, so hello everyone. As Asidora said, my name is Analia, and the idea for my project was to apply machine learning to the analysis of digital skills. And digital skills are competencies that allow people to take advantage of the use of new technologies. And because not everyone has the same level of digital skills, this concept is integrated in the analysis of the digital divide. And the digital divide refers to the unequal access and unequal use of technology. One can study many things about the digital divide, but I focus on the question which socioeconomic variables influence the level of digital skills of people. And I focus on the results of a survey from 2020 about the digital divide in Barcelona, and this had more than 2,500 respondents. So socioeconomic variables, I refer to the age, gender, income, education, occupation, but also the district that the survey respondents live in. And I wanted to know if any of these variables had an impact on the level of digital skills. Now, this was not part of the survey, so I followed the definition from the European Commission about digital skills. And after working a lot with the original survey questions, I was able to gather information about information, communication, and problem-solving skills from the survey participants. And with all these, I ended up with 2 categories: people that had basic or above basic digital skills, and on the other hand, those that had low or no digital skills at all. So statistically, I found that all these variables are connected to my index, but because most of the people have digital skills, one might be quick to think that this relationship is not very strong. However, I found that all of my variables are super important in determining who are those that belong to that small category that doesn't have digital skills. As I said at the very beginning, I also wanted to apply machine learning, and I went with classification trees because research says that they work very well for this type of analysis. It allowed me to work with my categorical variables, and the results are easy to interpret. Now, here are the names of the libraries that I implemented and which algorithms I tried. And they all had in common that they placed gender, income, and district as the most important variables to classify digital skills. However, because district is actually very related to all of my other variables, I took it out and I rerun my models. And in this case, they all had in common that gender and income were equally important to classify digital skills. Now, two of the algorithms place a bit of importance to education level. And for this C4.5 algorithm, it was almost equally important gender, income, and age. So let's look at this gender variable. We see here that, as I said, most of the people have digital skills. Seems that there's not really any difference between men and women. However, on the right, we see that small portion of people without digital skills, and we see that it's mostly women. And going back to district, this applies for Barcelona or any kind of city. We know that each part of the one city has special characteristics. And so, for example, one part has more students, another one has more rich people, and so on. So if we go back to our gender variable, we see that from those women that don't have digital skills, they mostly live in the district of Nou Barris and Eixample. And we have represented on the right the men without digital skills. They are, let's remember, a lot less than women, but they also live mostly in Nou Barris and Eixample. Now, our next variable that was so important was income. And we know that most of the people that don't have digital skills come from lower income households. And now let's see how this is related to our district. And here we have two colors. In pink, we have those districts with high income, and in green, those with lower income. Here, Sarria was the only district with high, it was mostly like 100% high income. And interestingly enough, Nou Barris is the only district in Barcelona that has 100% low income population, at least for this survey. Now, these other two were actually low middle income. And I found very interesting Ciutat Vella and Sant Martí, because they are the only districts that are a bit more polarized. It was almost 0.5% middle high income, and the other half was people with low, middle low income. And let's not forget about our age variable. And this is because when we look at that small portion of people without digital skills, we see that 70% of them are older than 65 years old. And that actually young people represent a much smaller portion. And if we go back to our maps, here we have points. The points are survey respondents. On the left, we see the only 13 people that were aged 25 to 34 without digital skills. On the contrary, a lot more points. This is all of those older than 75 that didn't have digital skills. And we also, it's not that easy to see, but we see that there's a bit more of concentration in this district of Nou Barris. So even though this was a very brief presentation, I want you to remember that why do we even care about these digital skills is because nowadays, if people cannot work with technology, means that they cannot apply to certain types of jobs that might give them a higher salary. So we know that places with very high digital inequality are places that have very high economic inequality. Second, I showed that machine learning can be used, as other research has done, to analyze the digital divide. And it might be an interesting approach for policymakers to easily identify which areas of their cities are the ones where they should have the resources put or have some activities, or even how to design policies to tackle this digital divide. And I would like to, before I finish, I would like to explain the biggest limitation from this analysis. And this is that the survey that I work with had zero information about software skills. So I think it would be interesting to go back, gather this information, and repeat the analysis to have a much more accurate picture of what's going on. And also maybe take out these older generations and focus the analysis on what's going on inside the active population. So thank you very much. And if you have questions.
Congratulations. I don't have a question. I have a remark, but unless anyone, So first of all, congratulations. I really think you did a good job. Uh, and I think it's especially important, this, because it is a way to characterize the people under risk of exclusion because of digital skills. And I think that this characterization, and in fact, I mean, it's kind of easily understandable, this decision tree at the end, and this could help politics to, put in practice the specific policies to avoid this exclusion. So congratulations. I think you did something that may have big impact in real life. So thank you.
Yes, go to Barcelona Council and propose this idea. Come on, yes. See, why not?
Yeah.
Claro, it's sí, super nice. I totally agree with Laura. And it's also like super interesting to see also because you were analyzing 2020, so it's after pandemics, no lockdown. That I'm sure that a lot of people, maybe all people, or not say, or not, or like, were kind of like evolving fast, no, in these technologies because we were all locked down, no. So maybe imagine these results coming from 2017 or 2018, no. So it's. See.
Yeah.
I had one question regarding the machine learning models. Did you directly did that one, or were you doing a different process, such as, I don't know, testing different machine learning models? Because you were saying that you were using one decision tree. Can you explain maybe to the audience?
No, maybe that was not clear. I don't know if I should show the slide again. I initially started with wait, I show fast. I think wait. We are here. Sorry for the. It's here. So it's not it's not here listed. I started with the classic scikit-learn decision tree, but I found out that it's some kind of modified CART algorithm. And then I came across this ChefBoost library, which works very, very well with categorical variables because you need to pre-process them. This library can handle these categorical variables first, and they had very good metrics. So I tried ID3, CAT, and C4.5. And there's minor differences between all of them, but they all had accuracies of higher than 85% for the test sets. And more interestingly, the F1 score was 91% or a bit higher for all of these models, which didn't happen with the scikit-learn, and I wasn't very happy with it. CatBoost, I tried it since it's a super interesting library. It's the gradient boosting for categorical decision trees. There's not a lot of documentation, so I got a bit stuck. I only know that it has very good metrics, but I couldn't explore in detail what was going on with the features. So it's there because I did try it, but I couldn't add it to the algorithms.
Amazing. That's what I wanted to listen, that it's like not only one algorithm and magic. No, you tested a lot of things, and out of this you selected the one that gave you the best accuracy, no, or the best results, no. Nice, congratulations.
Thank you.
Good job. Somebody wants to add something, any curiosity or something to Analia? No? Sure? Okay, so a big applause. Let's jump into Eva, which will be our second student that it's presenting.
Okay, I'll share my screen then.
Yes, whenever you want.
Okay. So, good evening, everyone, and thanks for joining the session. My name is Eva, and for my data science final project, I have chosen a data set of songs. Since my background is in linguistics, I have decided to base my project on natural language processing. So the dataset contains 28,372 songs, and 27,614 were in English, and the songs range from 1950 until 2019. The dataset is labeled by genre and topic, and it also includes the lyrics of the songs. The dataset contained multiple variables like scores for danceability and many others that I consider not relevant for my analysis. So my final dataset contained these variables: artist, song name, release date, lyrics, genre, and topic. I filtered out the songs that were in other languages and worked with lyrics in English only. And I downloaded the dataset from Mendeley Data. And here's the link in case you are interested. So to clean the dataset, I have applied natural language processing techniques. To pre-process the text, I have used the NLTK library to tokenize, remove stop words and punctuation. And I have also used the LangDetect library to filter the songs in English. I began exploring the dataset by checking the distribution of the songs, both per genre and topic. We can see in the first pie chart how pop is the most popular genre in the whole dataset, with a 25% of the whole dataset. In the topic distribution, we see that the romantic songs, which are the songs I have based most of my analysis on, represent the 5% of the whole dataset with 1,467 songs. I chose this topic because I thought it would be interesting to explore what is understood by romance and romantic using NLP techniques. Before moving forward and analyzing the romantic songs, I also wanted to check the most frequent words in the resulting dataset after the data cleaning. In both the word cloud and the frequency plot, you can see the most frequent words used in all the songs. So the words know, like, and time are the most common. And we can see how yeah is really used a lot, and surprisingly, I didn't remove the word from the stop word list to actually see how common it was, and we can see it's the 6th more used word in all the songs. I also wanted to see the evolution of the genres through time. In the first graph, you can see the evolution of the amount of songs per genre through the decades, so from the 1950s until the 2010s. We have fewer data available for 1950s, but from the 1960s on, we can see how the dataset contains mostly pop songs, together with country, jazz, blues, and rock. We can notice here how hip-hop started in the 1990s and how it has quickly evolved to be as frequent as the rest of the genres in the 21st century, according to the songs in the dataset, of course. In the second plot, we can see as well the amount of songs per decade that the dataset contains. I wanted to further explore the songs labeled as romantic, since I was curious to see if using NLP techniques, I would be able to see the subtopics of these songs and see if all of them are actually romantic or whether some of them contain some rather obscure topics, that is, something related to violence somehow, like stalking or abuse. I noticed that many songs have been historically considered romantic, but they are actually quite creepy and even violent against women sometimes. In the pie chart, we can see how pop is the genre that contains more romantic songs, followed by country, blues, and jazz. In the second plot, we can see how romantic songs have decreased through time and how common they were during the 1960s, but not that much in the recent years. I plotted a word cloud and a frequency plot to see the most frequent words in the romantic songs. We see the most frequent words in this case seem to be quite specific to this topic, like hold, love, or kiss. The fact that woman is a very frequent word, but not man, implies the fact that most romantic songs are directed to women and presumably mainly sung by men. So to further analyze romantic lyrics, I used topic modeling, which is a method for unsupervised classification of documents for finding a group of words from a collection of documents that best represents the information in the collection. By applying LDA, which stands for latent direct allocation, I obtained 4 different topics. I also tried with clustering, but the result was not as good as with topic modeling in this case, since I got like very many clusters, but they all had very similar words and topics. And here the word clouds represent the 4 subtopics. Even though they show different topics, I wanted to go a bit deeper with this analysis. So that through topic modeling as well and LDA, I divided the songs into three periods, from 1950 to 1975, from 1975 to 2000, and from 2000 to 2019. We see how by dividing the songs into periods, topics get a bit more different and more meaningful. Even though we cannot appreciate huge differences in the words per topic, we can see how we get 4 distinguished groups and topics and how these songs have evolved through time. However, an important insight can be drawn, and it matches my expectations at the beginning, that sometimes something is considered romantic, but it is not actually. In the second group, corresponding to the songs from 1975 to 2000, we can see how one of the topics includes words like knife or sharp. These words imply the possibility of these songs talking about violence in a romantic relationship, most likely against women. Also, the word virgin seems to be recurrent, which is also something that might be worth exploring in detail. To further explore the lyrics of the romantic songs, I have performed sentiment analysis using VADER, which stands for Balance Aware Dictionary and Sentiment Reasoner. Sentiment analysis aims to measure the attitude, the sentiments, the evaluations, attitudes, and emotions of a speaker or a writer based on the computational treatment of subjectivity in a text. VADER is a lexicon and rule-based analysis that produces 4 scores: positive, negative, neutral, and compound. The first 3, so positive, neutral, and negative, represent the proportion of the text that falls into those categories, as we see in the plots here. The final metric, the compound score, is the sum of all the lexicon ratings, which have been standardized to range between -1 for the most extreme negative to 1 for the most extreme positive. Even though VADER is mainly used for sentiment analysis on social media, I wanted to take the chance and test its performance on the lyrics, and I think it worked pretty well in this case. And finally, I have built a song recommender based on the lyrics of the songs of the whole dataset in English, not only for the romantic songs in this case. To build it, I have used the back of words technique first to vectorize the words, and then I have applied cosine similarity. Even though you probably wouldn't consider listening to a song because the lyrics are similar to other songs you liked, I thought it was interesting as well in terms of the topics the songs may cover, and especially interesting to use these techniques to build a recommender based on text similarity. So after this analysis, we can conclude that the topic distribution in our dataset is unbalanced. But even though romantic songs represent 5% of the total amount of songs, I wanted to focus my analysis on this topic, since I was interested in analyzing the lyrics of these songs to see if there were some interesting insights to be extracted from them. The analysis actually confirmed that there are some obscure issues and a deeper analysis would be required. We have seen as well how romantic songs have decreased through time, which may imply the lower interest that this topic gathers currently. As next steps, I think it would be very interesting to apply supervised machine learning techniques to both build a classification model to classify songs per genre and topic, and a linear regression model to see whether this downward evolution of romantic songs we have seen before is confirmed. As I have already mentioned, it would be very interesting as well to further explore the lyrics of the romantic songs to see if more interesting insights may arise to take this analysis up to the next level. So that's it. Thank you. Happy to take questions if you have some. And I'll stop presenting because otherwise I don't see you.
Amazing. I really love it. I mean, it's amazing. I want to see the results from the different genres, you know, not only romantic rock, for instance, no?
Yeah.
But I think that it goes a little bit on that direction, no?
Yeah,
but it was super nice to see, for instance, at least from my personal point of view, some insights that or suspicions, no, that we might get that, okay, romantic songs for sure that have something, blah, 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 to see it, you know, really with a model or with some, you know, data science perspective, you know. For me, it's super important because sometimes we have that feeling, no, or we know that, yes, that. Pero when we see that information coming after an analysis, it's super, super interesting. Publish a Medium article or something. I think it's super nice.
I'm so happy to actually be able to, through topic modeling, actually see, you know, what my suspicion was.
Yes.
Wrong.
For me, super interesting.
Thank you.
Yeah, I completely agree. In fact, it's, I mean, at the end with music, sometimes you are able to say some things that without music you would not say. And it's kind of a reflect of our society somehow. And it's impressive to see. I mean, you can really do, or you have demonstrated that you can do an analysis of our values through songs, and the insights that you took are, you know, kind of, I mean, we should be preoccupied as a society, and we should try to improve things in general. So yeah, I think Idolia's idea is very good. You could make some publication in some social media with the insights that you took.
Okay.
They are good for that.
Yes. Or in LinkedIn if you want, I think it's a good way. And also analyze the, you know, the romantic songs coming from the 90s, but I would focus on Spain because on the 90s in Spain, the movida madrileña.
Yeah, it's a good idea.
Telita, eh?
You're completely right.
The songs are completely inappropriate, eh? Super inappropriate, eh?
Knife will show up much much more.
Sí, super interesting. Congratulations.
Something that it was curious to me, it's the word no. It seems that people is really, confident on themselves because they know what you want.
They know a lot of things. Yeah, I was also surprised to see, this comes up so frequently.
Yeah.
No, I know.
Yes,
It's a
Virgin, no? It's in the second, I think that is in the second part, said Virgin, no? It's like,
Yeah, that's why. I mean, I was like, come on. I mean, that we quite obsessed still with women's virginity. So,
Virgin, and you were not pointing out what I saw, anemic. That it's like
anemic,
anemic.
yeah. That's also something super weird.
Sí, super weird. Super weird. Pero bueno, it's like that. So it's close to anemic. Blah, blah, blah. No sé. Cool. Congratulations. Somebody has a question, a curiosity, something you want to ask or comment, and so on? Somebody in the audience? No? So big applause for you too.
congratulations. Yeah, you did a very good job.
So let's move to our third student. So Ellie, Elizabeth, whenever you want.
a ver, que lo tengo aquí. Okay. So good afternoon. My name is Elizabeth. I am a process engineer in a melt shop. So my project is related to necessary ferroalloys in equipment that is present in the steel production. The name is ladle furnace. So the ladle furnace have two main function. The function, the first one is bring the steel to the required temperature in the next equipment, and the second one is alloy, the bath. Alloy is like cook. You have some additions and some ferroalloys, and they give the chemical composition required for its proposal, because it's not the same that if the steel is destined to the car industry that if the steel is destined to the building industry. So my final project is to calculate automatically the ferrosilicium necessary in the ladle furnace. Why? Because two main reasons. The first one, safety process. Because if you calculate this one automatically, you reduce the time that the operator have to be outside the desk, no? And so less risk. And the second one is a standardized process. This is to study better the deviation or some improvement on work with standardization processes is all time better. So to train the algorithm, I have selected a data set that has input variable. That input variable are related to the state that the steel arrive in the ladle furnace. So this is temperatures, waiting time, slag composition, addition in the tapping, and the first analysis that we have of the steel in the ladle furnace. And another kind of input is the variable that say you the requirement that you need in each kind of steel. So all of them is to give me the output variable that is ferrosilicium. After cleaning, I have 54 variables. So when I put all of them in a pipeline, obviously I have overfitting. So I need to clean the variable. The next step, I need to eliminate some variable. I did a process to study the variable and see the dependence between them. And this example, we have a different variable that have a very high correlation between them. And this is because they are a different kind of acidity. They are very similar. The only thing that they have different, it's a different component that they have in the denominator. So I eliminated and I did a matrix correlation to and study the relation between other variable, and I deleted two. After I studied the distribution of the data of my output variable, and I see that, okay, maybe it's a normal distribution. And when I did the training of the algorithms, I said, okay, I recite 0.57 of R squared. And I say, okay, it's fine. And I studied to the algorithm transformation. And when I did the same training to the model, I get a worse result. So yes, it's enough. I think that no, because the result is very low. I have a lot of variable, so I have a lot of noise. No, so I pass to study the relation with my variable output. The ferrosilicium is used to give the steel bath the silicium necessary. So the problem is that the silicium is friendly of the oxygen. So when I group the variable between high and low oxidation, we see that the high oxidation need more ferrosilicium than the heat that don't have a lot of oxidation. So this is another graph that shows the same behavior, but with another variable. This is the first analysis that we have of silicium in the laser furnace. This is a group by. I use another variable to consolidate this behavior with the line. Line is a desoxidator. So we can see here that when we use more ferrosilicium, we need more line. So this is the behavior expected because it's an oxidation reaction. No? So another thing that is very important is the temperature and the waiting time, no, between each equipment. So finally, I decided to the PCA, and here we can see the variable that have more impact, no, in the variable output. So here I see that it's too difficult to see something, but all of them are related with this characteristic: oxygen term and temperature term and waiting term. So finally, I get 25 variables. This was the result of the training model. I decided to go to linear regression model because this one spent a lot of time, and maybe I'm going to repeat when I come back at work, because with my computer, this one was easy for me. We can see here the graph now with the prediction and the real, but we have a lot of dispersion here and a lot of sum here. So I studied the normal distribution with these two ways, no, and he said me with the p value, and that is not a normal distribution. So ahora, yes, I think that now it's the beginning of a good model, no, to try to calculate automatically this output. So conclusion on the next step, the oxidation and the composition are very important in this variable. So I'm going to start to analyze another kind of slag in the laser furnace. I'm going to use more data about the composition and calculate and use the calculate of the kinematic of the reaction. Trying the algorithm, because this data is only 9 months, and for iron steel is a little bit less, and clustering the data, because when we group by, the behavior is very, very near, and check with another kind of algorithms. So the other day, I reading this in a book, and I remember you ladies a lot of, so I thought that could be great put here. Creímos en el conocimiento en perjuicio del status quo. Elegimos la epopeya como Aquiles, elegimos la manzana, y es algo que jamás nos perdonarán. Thank you. A ver.
I love the quote. never stop learning. I don't have much questions, but I would just like to highlight, well, this is the most technical project that we have seen. I think for the topic is pretty new for most of us. But I think you did a very good job understanding and analyzing all the different variables that you have. And it's good that you revise your outcomes constantly to see whether that is enough or not and what should be the next steps. In fact, okay, I think 70-something% of accuracy is pretty good for a model that you have developed that within 3 weeks. And for different categories of steel production and et cetera, and different complexities, that was not a data set that was already prepared, to do the course. So I think you achieved a lot, but you still have a roadmap to keep continuing learning and improving the model. I just have one curiosity. Which accuracy would be, let's say, adequate to bring that into production in the company?
So we are working with another models, and it's more or less in this accuracy. But I'm going to try more time because yes, it's nice, but the accuracy is nice, but how many is the difference? Because if you move, it's very sensitive. No, if you move 50 kilogram more, you change the quality of the steel. So I would like to try in the production now to compare more the data, because the result is it's fine, but I don't know what about the sensitive, la precisión, ¿no? Exacta del modelo. Sí, pero está bien.
I think you can play a bit more with the transformations of the different variables. I think you have room of improvement there from what you have shown so far.
Sí, creo que sí.
Gracias. But good job, really. Quite impressed.
Yes, I wanted to point out also that, this is something coming from real data, as Laura, I totally agree with Laura, but it's something coming from real data, coming from, the reactions that they are doing there in order to produce steel and so on. So it's more close to reality. Reality in terms of everything is real, I know, but reality coming from something, from a business, from a business question. So some application of, like I say, machine learning in order to improve one process that it's already implemented and it has, a lot of years running on and so on. Okay, so I also want to congratulate you because it's a good 0.70 something in terms of accuracy. It's pretty high, and I know that it was not just one model, and I know that the effort and how hard it is to get those values. So congrats, and keep on with that. Present everything to to your how is it called, to your bosses or managers.
But we invited them.
Super nice.
You should have invited them.
Claro, that's true.
Sí, no, mi manager se lo ha visto. Supongo que al ser mío el algoritmo me da más miedo, ¿no? Porque si otra persona de fuera me viene con un algoritmo del 0.73, le digo, vale, perfecto, vamos a probarlo.
Yeah, no, but I think that you should, now it's like, taking into account that it's 3 weeks, I think that you should stop and do it like more step by step, no? Because sometimes you're like, maybe I have to deliver something, so step by, and for sure that it's going to improve a lot with the different treatments that Laura was suggesting, and, and looking, carefully more everything, and diving in. Pero amazing, good job.
Yes.
Somebody wants to add something, comment something? No? Vale, so let's go with Pau, last but not least. Okay.
Yeah.
Whenever you want.
I will. There you see, no?
Yes,
we can see.
Oh, okay, no, okay, there. So the project is about the voice of the customer. That's how it's called. And I start with a quote from Kate Zabriskie. She's a business consultant focused on customer experience. And she says that the customer perception is your reality. And this will lead the whole project. So I find it accurate to share. So this will be about Wallapop, which is a company founded in 2013 for buying and selling second-hand goods. It is currently ranked on the 4th position for e-commerce and shopping in Spain, according to SimilarWeb. And it's already available in 2 countries, Spain and Italy. So which was the process for this project? It was gathering the data, scraping data from Google Play service, getting the reviews, then do some exploration, define objectives, clean and dig in a little bit in the data, then apply the model, learn and iterate quite extensive, and then come up with some conclusions and next steps. So what is it that we have from the distributions? We got like mostly the reviews. Okay, the reviews goes from 1 star, which is the lowest one, to 5 stars, which is the best score. And if we can see in the graph, in the pie, there you can see that there are pretty good reviews. 68% almost are for 5 stars, and then the pie is divided between 1 star and 4 stars, 12% each. And one other feature that it was important on our discovery of the data is that 10% of the reviews are voted. So you know that in the Google Play Store you can vote a review if you find it accurate or you find it interesting and you agree with it. So this gives more visibility to that review. But if we match these 2 pies, we can see that instead of having 10% voted and non-voting 90%, you can see here that the 1 stars gets higher votes than the other reviews. So it almost like doubling the proportion. So with this scenario, I proposed like 2 objectives. One objective was understanding the customer main pain points, focusing on reviews of 1 star. And the other one was understanding customer main interest or what is delightful for them, focusing on 5-star reviews. So starting with 1-star reviews, first, around 2% of the reviews were removed since there were like a mistaken user assignment of the review. They were saying that they were satisfied with the application and they were rating with 1 star. Also, some others were like bad reviews, but with not quality feedback. That means like they were saying, I don't like it, or I find it bad, and it doesn't give us to our main goal, which was understanding pain points. And on the 3rd place was removing some blanks or punctuation marks or icons that we cannot directly interpret right now. To have an overview of what's inside of the reviews of 1 stars, we can see that we got like messages, comments around the chat, the ads, the products, the account, the notifications, the photos, and also in terms of verbs or actions, it's like something that it works or it doesn't work inside the apps, things that are received or not received. This is in Spanish because all reviews are in Spanish. Also regarding the uploads or regarding the selling. And this is an overview of what we're going to see next. In another feature for exploring the data was that it was interesting was like looking after if there were like competitors mentioned in the reviews, and we can find that 5% of our 1-star reviews have at least one competitor mentioned. And here are the competitors and rank according from left to right according to its visibility regarding the mentions. So with all this, I'm focusing on the topic on the main point of finding pain points. I try to do some topic modeling, vectorizing, and clustering. I try GFIDF and LDA, DFIDF and K-means clustering with different hyperparameters. Also word2vec and K-means clustering, and I find it like there were no good clustering results, like I cannot find like topics. Then I also try sentence transformer and K-means, and I find some common clusters, but not super good. And here on the right, behind the girl, there is like a small chart where I plot the word2vec information that it was multidimensional into 2 dimensions, so as to see if I can visualize how it's this multidimension scene. And we can see that here is like a mass of whole dots, and there are like not super neat clusters to be grouped at the end. That was the main goal. So I start like to understand what is inside, more like explore manually what's inside the clusters, and I find like, yeah, there are topics regarding chat does not work, message not arrive or not sent. There were comments regarding the experience of buying and selling, also about the uploading photos or when the app crashes or fails. But then I have like my first point of critical point where I try to stop and understand what I was doing, what was this giving me value or not. And so I find out that what I was doing of checking reviews of the clusters was super time consuming. I was introducing a lot of high errors by doing it myself. Something interesting was like reviews have mixed topics, like it was not like saying one topic, it was saying many of them in the same description review. And something like it was positive of doing this also was to identify that there were like certain structure for certain topics, the way they express their claims or their pains. And particularly, I guess that the main learning was that with this, I was not able to quantify exactly the impact of these claims. So I asked myself how to do this topic identification easier and to be more automatic and probably more trustful. So with the previous learning of identifying patterns, I explored the n-grams, and then after that, applying NLP, sentence transformer, and clustering. And so keeping on the 1 star again, I tried bigrams, 3 grams, and also 4 grams and 6 grams. And then at the end, I decided to keep only the 3 grams. And I find that we have repeated issues expressed like differently or slightly, sometimes at other times was more differently, but there was a pattern that I can understand. And so after that, to those 3 grams, I apply the sentence transformer and the K-means for clustering, and I can get the different clusters, which is topic or the user pains in this case, and see that a little bit more than 50% of the bad reviews were according to clusters, and this gives coming actions for the business. And so with this knowledge, I try to apply to, let's go to our second objective and try to apply the reviews to 5 stars. And I do the same, apply sentence transformer and K-means to the 3 grams, for this case 5 stars. And in here, the clusters were, they were clustered information, but the information or the shown was more regarding the core brand awareness information, but not about the interest of the users. And here is one cluster that also groups, the one that is highlighted, that also groups some issues identified. So going back to the objectives and the conclusions after using n-grams, NLP, and supervised models, I could say that understand customers' pain points it was a good solution, this path. However, I would say for understanding the customer main interest, there was in this scenario, we are not getting further information. I wanted to know what delights users, and I didn't get that. It was more like the information of the brand awareness. And so here it's me with the next steps to work ahead. I would like to apply this also to the Play Store reviews, because all the analysis was done for Google Play. And also apply to 2 and 3 and 4 stars to check how it works. Then also analyze competitors' reviews and check if by identifying their pains, it can lead towards opportunity or leveraging features on Wallapop site. Also analyze and try to check the scalability of this process by applying it to another market and not only Spain. And probably investigate other algorithms and check if I got further with more conclusions or better even. And yeah, that would be all, and that's me. Thank you for listening.
Congratulations. Should I start? First, I would like to highlight that you have gone through a very, very exhaustive and deep analysis. And it was not easy, and I think it had more complexities than what you or saw at the beginning, because this is not a text from a novel or people that write things properly and that have clear things in mind. It's just people that when they move is mainly because they are angry. When they are happy, they may not say anything. This is in fact something that you see, because the bad reviews that you had with 5 stars, people didn't, you don't have coherence in your data. That's life, because people don't care much. They just wanted to say that something was wrong, but they still put it 5 stars. Sorry. So given all the complexity that people write as they do, without taking much attention to what how they write that, you found an interesting process to automatize all this process and still be able to get some relevant clusters. And that was really not easy, because as you saw in the latent space map graph that you showed in that plot, the reviews are usually close to each other. So at the end, if you want to split within several clusters, it's really challenging. Sometimes it's not even possible, but still you identified ways to do that. This 3-gram split or reconstruction, however you want to call that, I think that was a clever approach. That was really useful to identify at the end which are these topics. So congratulations. It was not easy. It's kind of the same like Elizabeth. The data set that you got was completely real, with all the challenges that has. And you made it. So nothing more to say. Congratulations. You can really be proud of yourself.
Thank you.
Absolutely. I agree with Laura, because it's not easy to work with text, to scrape data. I don't know if scraping data was not included in the course, so it's an extra topic that can last 1 year to learn how to scrape data from Google Apps, or whatever platform, so it's not easy. One suggestion that I have, that maybe, one suggestion, maybe do this name entity recognition. So just select adjectives, nouns, combinations in between adjectives, nouns, adverbs, because, maybe not, maybe it's not properly working, but zoom in, because if I'm thinking, for instance, in reviews coming from restaurants, that it's something that we all know, because I don't, add any review maybe in Google App Store, but in restaurants, yes, What I'm doing always is, highlighting and putting a lot of adjectives and nouns, in order, if the food was delicious, okay, an amazing chicken or amazing blah, blah, blah. if the food was disgusting, it's like disgusting chicken, no? So maybe zoom in, and rather than use all the clouds, no say, you need to speak with linguistics that are the ones that know better the language than me, but maybe sometimes it helps in highlighting or enhancing these clusters. But I totally agree with Laura, it's super complex, especially with reviews coming from an app that, well, are coming from people that maybe doesn't know how to write properly, or they are like doing fast, they are angry, or they have typos a lot, no? And these kind of things that it's kind of complex. Okay, but bueno, my suggestion is that one try with just adjectives plus nouns or combination of multiple things.
Regarding the typos, just to mention, she even found smileys, emoticons, emojis.
Claro.
So
claro.
yeah, this is really challenging.
Yes, a lot. And also like, whoa, or hi, these the kind of things that it's normal, no? I'm super angry. That it's typo, no? To emphasize something. But yes, super nice. So I really love, the attitude that is like, okay, yes, but in the end, I reached that one, and, this persistence and so on, and okay, I want to do this, and it's fine. This is the attitude, because we have to all consider that you all have 3 weeks. So any project in which I was involved lasted 3 weeks just.
Ida, do you understand me now? Why I'm always so exciting with monitoring these projects, because they really do a great job in just 3 weeks, not full time. So it's amazing.
It's amazing. It's amazing.
I learn more than them. They don't know that, but I do.
Absolutely. So do I. Bueno, somebody wants to ask something to Pau, or any suggestions or something? No? So, well, I believe that, maybe Laura can talk, no sé, can say something, but I believe that you all did a really, really great job. I don't know if Laura, that you were her teacher, want to add something?
Just that, well, they know it has really been a pleasure to spend 3 weeks with you. All the process is really interesting because of the learnings, because of the challenges, because the life cycle of this kind of project is always the same, but doesn't make it less interesting. And for me, it's kind of really exciting to see how you go stage after stage, and you keep persisting and fighting, and you keep the motivation to get the final results of the project. So you have worked really hard, a lot, for your individual and different projects. I'm really proud of that, and I hope I have helped on that process a little bit. And just to congratulate you, really. I think you really deserve definitely some holidays during the next few days.
Yes, absolutely. Well done, ladies. So, well, I don't know if you want to say something to Laura. Otherwise, if you want to say something, otherwise, well, good job also, celebrate this. And this is the beginning of something really beautiful. Just
enjoy.
Be 100% and enjoy,
Just remove all your fears, okay?
Claro.
You are prepared to really rock it. You have the tools. More important, you have the soft skills. You have demonstrated that. You know how to look for additional information. You have tried new things during this project. It has not limited to what you have learned so far. So you're able to get into the real world and face real problems you have done so far. So yeah, don't hesitate, or trust in yourself.
Go for it.
You go for that. Thank you. Yeah, exactly.
Vale, amazing, ladies.
Thank
you want to say
something?
Thank you, Laura, and all the instructors. It's been a pleasure. It's been hard, but it's been a pleasure as well.
Being there listening also to our crazy days.
Yeah, and you really helped us to go out of these bad days that we had, and you gave us so much clarity on how to continue. It was really amazing to work with you.
Thank you. Well, we have all been in this stage, and it also happens when I am the one that are doing the project. I still keep this momentums up and down. So I understand you, and this is why I also want to share and help. So thanks for your words, Analia.
So I would like to say that thank you to Laura, and thank you for all the teachers that we had before, and allWomen, because I think that the analysis of the data, it's never finished. No, this way it's never finished, and I think that it's a hard way because have a lot of different focus, no, but I think that now we have very strong tools, and so thank you, and we continue work, but not together, but we continue work. Thank you for all.